Welcome everyone. Good evening. Can you hear me, everyone? Let's start with that because most of the time we always have audio video issues. Are you able to hear me? Just type thumbs up or like yes, no in the chat box. Good evening, everyone. Great, perfect. So my voice and my audio both are audible, right? Video and audio, perfect. Great. That means we all are excited here to listen what exactly is going to happen here. Right? So let me welcome you to the first ever chip design program for high school students that's happening because of Intel, IIIT Bangalore, VLSI of India, and VSD, where we are like, you must be really wondering why chip design to high schoolers. But let me give you a little more perspective about high schoolers. Today, if you read newspapers, internet, everywhere, high schoolers are designing satellites, high schoolers are designing apps, they are designing some billion-dollar websites, and there are so many youngsters who are doing which retired persons are also not doing. So I think this generation is really fast, and they want to learn quick, they want to adapt, and they want to apply. So this generation, I really appreciate the energy that they are having, and I respect the work they do. They research, the type of research they do. Means like sometimes I really wonder how these people have that curiosity to learn about how the satellite goes up, how the satellite can weigh low, like low weight, and how when the Chandrayaan recently when the Chandrayaan 2 and 3 were launched, the amount of energy that was shown on the media by students, oh god, really appreciable. And I'm really happy the people from industry and academia are taking an initiative like this, where they want the students who are developing the applications in satellite, in apps, in websites, in games, what exactly is happening behind the screen. If you see, today's generation is a gamer generation. They like to play games using mobiles, using Nintendo Switch, using Xbox, everything that is available in the market. But I'm really very curious to understand whether the students know what exactly happens behind this. Any one of you know what exactly is behind the screen, which is shown on my screen? This is a Switch, right? This is a Nintendo Switch. Have you seen this before? Every one of you? Have you seen any type of this type of switches? Like a video game or something like that, which we play with the buttons? Have you seen? Yes, great. There are people who use it on a regular basis because these days digital life is so common after the COVID thing that's happened. Everyone knows, all the smaller, younger kids know to use all the gadgets, everything. Like many of the students, they are so well versed with all the gadgets now that we have to learn from them sometimes. So this IIIT Bangalore and Intel, they thought, let us open this forum for the high schoolers and let them understand how exactly the chip, which is the brain of this complete gadget, how is it works, how it is designed, how exactly it is manufactured, what exactly is the whole process, the whole cycle of a fresh product which is sitting in your hand. There is something which is happening. There's a huge science, huge physics which is sitting beside the screen, right? So let me just invite some of the people from the industry and the academia who will give you a little more perspective why this program is designed. Let me first invite Professor Madhav Rao, who is the torch bearer of this complete program, who has given this idea where we can initiate this small movement in the students era, where in the high school era, where we can make them understand chip design, let them design their chips, and let them put their chips in their own gadgets, like whatever they want to design, whether they want to design a satellite, whether they want an IoT, or they want to design a gaming switch, whatever. So let's invite Professor Madhav Rao, and we can ask him to talk about his initiative. What exactly was in brain when he initiated this program. I welcome Professor Madhav. I will request you to unmute and turn on your camera to give your more insights about this program.
Yeah, I have turned on my camera as well as unmuted. Hope you are able to hear me. Let's see. Some issues with my... Okay, I think the students or whoever has participants, they are able to hear me. Okay, so I'll get started, Anaga. Thanks for the nice introduction. And really, I'm really glad to see this particular forum where we have a lot of students who are looking forward to this particular meeting. And it was all possible because VSD, Kunal, and you have put together a nice charter, or rather a roadmap. How we are going to deliver this particular program. All right. So I'll, as you have rightly said, I think this generation of the students, or I'll call this as an AI generation of students, they are, it's unmatchable. Lots of energy, in not only in one particular focus area, but in different verticals. And being at IIIT, I see, or I interact with students, every now and then, and I could see that this generation of students have a lot of potential, a lot of energy. Uh, and in that case, I think we feel that I'm very fortunate to be an academician, working with this generation or this set of students. So coming back to this particular program of a VLSI awareness program, this was actually a brainchild of, I would say, an Intel program head, Mr. Sumit Verma. So he happened to visit my office and then had to discuss with our director, Professor Debabrata Das, sometime last year, and then he initiated, why can't we inculcate the VLSI skills at a very low level, in the sense, at a possibly at a high school level, or possibly at a college level. It doesn't really, whether it is possible to inculcate all this technologies, the VLSI technologies, right at the beginning of the career, so that everyone will get an opportunity, or everyone will get an awareness about the VLSI, and then they can make a, they can make an informed decision about whether to proceed further in the VLSI field or not. And I think this was at the right time. I would say what Sumit mentioned, that one of the closed door interaction rooms, and he made a valid point, stating that why not we do this, because these days the high school students, or even the diploma students, or the college students, of any branch, maybe the students from in a commerce branch, or the students in an art field. Now they are able to develop the mobile apps, which will help their domain, to enable the creativity and all those things. So they are well versed with the app development. And is it possible to have, a VLSI kind of an ability to bring down that VLSI ability at that particular level? That was a very, I would say that was a very ambitious idea. And my answer at the first instance was, we don't want to take this high risk. But, after a couple of weeks, I also had a discussion with Kunal, and I think at some point of time, beneath ourselves, we felt that I think this is a very ambitious one, but I think it is the right time for the India. This is the right time for the generation, next generation of the students, to begin the VLSI, the thinking about the VLSI program right at the, when they are molding their careers. So that's when we came up with this an idea, and then we pushed our proposal to Intel, and Intel were very, very happy to see that there is something, a strategy, or there is some kind of a project which we are trying to take up. And so that's when I think this whole program emerged. And so we are in a hope that we will be able to take up this challenge, deliver it to the right set of students, deliver it to the highly energetic, highly motivated students, and bring down this particular notion of VLSI being very, very tough, very, very challenging, and it's only for in a niche class of people. We want to bring that down to everyone. So that is how I think we have envisaged this particular program, and you could see that we are going to talk about a lot of basics. We are going to start this program with a kind of an open source hands-on lab, and then we are going to diverge into the theory part of it, and then once again go back into the hands-on lab, and then once again seamlessly move to the theory part. So the overall program structure is like that. You get an interest, and then understand the theory besides it, and then once again move to the lab part, and then once again move to the theory part, so as to make it very, very interesting. And at the same time, at every lecture, you should be able to take home some of the things which, as a student, or as you are moving forward, you should be always constantly thinking about this. So at this point of time, I'm really glad to see a lot of participants. I noticed that Kunal messaged me saying that there's more than 1,000 participants, and so I'm very excited for this program, and looking forward to deliver this program at full fledged. So over to you, Anaga.
Yeah, thanks a lot, Professor Madhavram. And I really appreciate that. I will just share some stories about when I was doing engineering, doing any program with the prestigious university like IIIT Bangalore would be having dream for any student. But today I can say because of Intel and because of IIIT Bangalore's initiative, the students are so lucky that they will be able to interact with the professors, with the experts from the industry, from the academia, and learn what's exactly is happening inside the gates, which is really tough to crack as a entrance exams and be inside of these colleges, right? I'm really happy that you guys have opened up opportunity for the students to learn, and they will have a broader vision when they come inside these universities and they come inside these industries, and they can make some great miracles. So before inviting the next guest on this panel, let me just ask you a question. How many of you here have heard a word called Intel? Anyone has seen this word Intel anywhere on your gadgets? Where on the gadget? What exactly is written on the gadgets? Yes, correct. Intel inside, Intel chip, i7 processor. Great. So let me just give you some more details about Intel. Intel is the first company which was started using this microprocessor. When the founders of this company were the scientists who have developed the transistors, who have developed the microprocessors. So this company is the inception of all this VLSI era, I can say. And we are lucky enough to have a person from this company, a veteran, Sumit Sumit Verma, who is the brainchild, as Professor Madhav was saying. He is the person who has promoted this idea and who has opened up the gates for pouring the new generation to in this knowledge, where they can learn, where they can apply using this open source tools and make some more type of designs which they can develop using their gadgets and applications. So is Sumit available, Kunal? So I think he's busy with his tight schedule. I think he was traveling. He said he might take up the call, but maybe he's not available and network is not available. So let's just go ahead and we can invite our next speaker, Dr. Satya Gupta. Again, I have very my words will be very less to describe his career path in this VLSI industry. He also started his career from this great industry, Intel. He had taken lots of initiative in Intel Microelectronics to promote VLSI industry in India, start the VLSI industry in India, where he came to India he studied in India, but he had gone to US for some time for his initial stage of career. When he came back to India, he was the torch bearer of the complete VLSI initiatives in India, the design hub of India. So let me just invite Satya Gupta sir, where he can give us about the more inception, more broader view, what exactly VLSI means to us, what exactly a chip design means to us, and how important it is today for India at this junction to learn chip design, to grasp the knowledge and become the leader in chip design. I welcome Satya Gupta sir to open up the mic and camera and give a broader perspective to the students about what exactly is VLSI.
So good evening, friends. To join this basically important, I just want to start with the how many chips
Sir, your voice is
do you
resonating.
use every
Satya
day?
sir, your voice is resonating. There is a vibration, a little bit vibration in the voice.
Actually, I don't see any echo.
It's vibrating.
Resonating.
It's resonating. It's like spring voice.
You can try again, sir.
Let me try again. Maybe is it better now?
No, still it's resonating, sir.
Now,
Sir, it's resonating. The voice is resonating.
let me log out and log in again.
Yes, sir. We can. We can wait. Till the time Dr. Satta sir will be back, I'll request Chitra ma'am, who is also one of the veterans from this industry, who has gone with a long journey, and she also started her career as a graduate engineering trainee from the same industries. But today she has so immense knowledge, and she is also a mother and a parent who has also promoted her child to be in the technology. And the person who understands the technology, who has promoted her kids to be in the technology world, and now she has taken up an initiative where she's spreading the knowledge under the VLSI program to different universities, and she's taking these programs to different colleges in tier 1, tier 2, tier 3 high schools, where she wants to see how this can be spreaded using this channel VSI. So I request Chitra ma'am to please come up and tell about your perspective about, as a parent, as a technologist, and as a VLSI head, where you want to see these things go, where you want this program to go ahead.
Thank you so much, Anaga, Kunal, Intel India, and IIITB, Professor Madhav Rao, and Sumit Verma for starting this program. I mean, this is a great initiative, I would say. So first, hats off to you all to start up this, and then, I mean, we will have to deliver great on this, is what I would say, just to start. I'm so happy to be part of this panel today with all the esteemed people over here, and with all the students, right? I mean, they are the ones, I mean, who bring the highest energy to this forum, right? I mean, I really wish I get to see everyone. I mean, my energy also would get pumped up. Anyway, with all the logistics things, I mean, I know that, I mean, we cannot see everyone. I'm really hoping that we will have one program wherein we will have everyone in person, maybe at least at the end of the session or whatever, to see this highly enthusiastic people, I mean, who are wanting to be part of this industry, right? Anaga, if you could enable that, Anaga and Kunal and Madhav and Intel folks, it would be really great. Okay, just to get on, my passion has always been somehow, for some reason, I got pulled towards hardware in the very early part of my life, because I've taken electronics and communication as a career, and anything that works, right, I mean, started exciting me, right? Like, I mean, you want to see things in action, right? I'm sure all the kids who are participating would also be wanting to see that kind of the that kind of the engagement with the gadgets that they carry, and with they would want to design their own gadgets, right? I mean, is what I would say. I mean, moving forward, right? They would want to be designing their own gadgets. They would want to be designing their own chips, right? So the drive that we are doing now would definitely enable them. Today, they're all doing, they're creating the app, they're creating something that they feel excited about. But if they start creating the chips that would get into the gadgets like this, which they get to use daily, right? I mean, that would be the ultimate happiness, is what I would say. So that's the kind of the thing that I got latched on. I mean, to design my own things, or to see something working which I have designed. That's what got me into this career, wherein I started designing some of the products, and then I started attaching myself and seeing this excitement. And then my son also got excited, and then started getting interested to see what is happening in some of these gadgets, and then how will I be able to design some of these things. So this is the natural curiosity that gets developed when you start thinking that, I mean, I'll be able to design my own chip. I will be able to design my own gadget. I will be able to design my own device, right? That was the one that started exciting him. And then he got into this career path. And then, I mean, today he was with Intel and then now he is with NVIDIA. He did his chip design as the career path, and then I mean he's really progressing well. So as a parent, I mean whatever decision that we took between me and my husband is really paying off. So if there are parents who are part of the call, I would really encourage them to have your kids encourage them to be part of this hardware, taking hardware as a career, as a good career option, because that's going to, according to me, hardware is a evergreen career, right? You would always have opportunities. There could be things in the software world, I mean, that keeps changing, but hardware, according to me, is a evergreen career. And then I've been in this field. I started my journey from 86 onwards, and then I mean till today, I'm pursuing my career, and then I'm really doing good in my capacity, right? So that would be my encouragement is what I would say. But if there are specific questions parents have, like, I mean, why they need to be taking electronics or hardware as a career path? Is it easy? Is it tough? All those things we will be addressing. One thing I would say is hardware is not hard at all. Right. I mean,
That's true.
once you start developing things, the excitement that you would get would be very, very different. Right. I mean, software, the apps, when you look at it, you all feel that I developed this app, this picture is coming. I feel you get excited, right? But if you
Yes.
start thinking that the foundational thing wherein your app is running is also designed by you, right? The excitement that you carry would be very, very different, is what I would say. If we can reach Chandrayaan kind of the ambitious goals, right? I mean, we would be able to create that kind of the excitement and interest in the community that are here today, right? So all the very best, and I'm here to help you all with any questions or anything that you have throughout this journey, folks. Okay.
Thank you, Chitra ma'am. Leaders like you and Satya sir and Madhav and Sumit sir, this are the reason why this type of initiatives are really going ahead, and it's taking up shapes. Like, you know, everyone has a vision statement to let's do this, let's give back to the society, let's do this. Like, people talk, but very few do, and you are the few people who have taken up the initiative and, you know, taking up the efforts how we can take this ahead, how it will reach to the real learner. No? So this is a tough task. I really appreciate ma'am and everyone here who is going to join us for the next 3 months of program and help to mentor these kids who are really interested to learn. Thanks a lot, ma'am. So I think Satya sir has joined back. Let us welcome him on this call and listen from him. He has great perspective and really he's going to give you a bigger, broader vision about it. Satya sir, I hope you're back.
Thank you. Thank you, Anaga.
Yeah, I'm
Thank you.
back.
Chitra.
I don't know if my audio is okay now.
No, it's
It's
better.
good. It's
really
good, Satya.
Yeah.
It's good.
So, good evening, everybody. All the student, parents, and anybody else who has joined basically this evening. I think large number of you joining today shows that basically you are interested in learning about the technology which today governs almost 50% of your day-to-day life, and in coming 10 years probably it will start governing 80% of your life. Anything you do, anything you touch today has basically electronics and semiconductor chips inside it, right? Just a question for all of you. How many chips you think you would be using every day in your life?
Maybe more than
You can put your
50?
answers on the basically chat box or something, right?
More than 10.
So I'm
More
saying
than close to
answer
50.
5, 6, 10, right?
Yes.
Today, probably you are using more than 100 chips throughout your basically the time you wake up and time you go back to sleep after basically watching couple of hours of movies on your video on your laptop, right? So that's where we are today, and it's but obvious that you get exposed to this technology early in your career, right? So you know what is basically driving everything around you, right? Uh, a small thing like GPS, right? You use the maps every day. Almost everybody uses it, right? How does this whole thing work, right? There are a couple of satellites up there who use again a lot of electronics and a lot of chips. They beam the satellite location to your mobile phone, where basically a small chip is gathering the location of all the satellites, and based on that, uh, they calculate where your position is. Maybe during the course, we can cover that how your position is calculated by using the satellite's coordinate, right? Maybe
Correct.
Anga, we can run a half an hour session for the kids during the
Of course,
course
yes.
to just show them that how your position is calculated and how the maps work, right?
Of
So
course.
that's the kind of the importance the semiconductor field over last 40 decades, since basically early uh, 80s when the transistor started basically getting there. I had a good fortune to work for Intel from early 90s, being part of basically a lot of processor generation. How many of you have heard the name of Pentium processor?
Pentium 5 was the most famous version.
So I was at the time basically when Pentium was launched by Intel in 1993. Obviously, at that time I was a young engineer, just like some of you would be in a couple of years. So I think uh, the whole idea about this program and other initiative we are doing in VLSI Society of India to develop early interest in electronics and semiconductor chips, right? Uh, it will take some basically knowledge and learning for you to get to where you design, but at least if you understand what basically these chips are, how are they designed, and how they are basically used in basically gadgets which you are using. If this course make you get interested in the most important technology which is around you, right? Uh, every software, every AI, every ML, data science, or whatever you hear as the applications, right? UPI would not have been possible but for the development of the semiconductor chips over last basically 4 decades, right? Uh, so I think take this opportunity, learn about it, and as Chitra said, uh, through these courses and other initiatives, right? We want to make chip design almost as easy as writing a basically Python code, right? So if you can write a Python code and compile in basically a couple of years down the road, you should be able to write basically the code for designing a chip and design your own chip or join this great industry. Uh, um, Today, I think this is one of the industry where there are a lot of job opportunities once you graduate from basically your respective courses, and very important basically type of the roles you get, uh, which basically both financially and technically very satisfying as basically people who have joined this career like Chitra and other people, right, have made. So thank you once again for uh, joining this session and make a complete use of this opportunity to at least get some basics and get interested in the field, so that basically down the road when you join the college, you can choose this as a basically career. Uh, Semiconductor field will continue to drive our lives for basically coming decades. Thank you so much, and thank you for IIITB, Intel, VSD, and all the basically instructors who are going to be teaching you all the courses. Anytime, if you need any help from myself, Chitra, and other people, uh, you can write to us. I think the easiest will be basically connect with us on the LinkedIn, and anything basically you need to know, have a question, or basically you need to talk to our advice, please basically write to us on platforms like LinkedIn. We will basically assure you that we will respond to you in next couple of days after we get your query. So all the best and good luck to you.
Thank you,
One
Satya
quick
sir.
question.
Yeah.
There is a question about why did you choose semiconductor as the interesting domain? Did it happen by chance or you chose it? That's the question.
Okay. So I think semiconductor was a choice after my PhD, but after my BTech, I graduated from BITS Pilani, and I had a choice to basically go towards hardware or join TCS, right? So we did not know that much those days, as you guys are much more knowledgeable when you are basically in 10th grade, 11th, 12th, right? You know much more about the world, about the technology. We just basically, I think at that time, not choosing the job at TCS and basically choosing this as a career, I will say was pure luck. But afterwards, after I did my MTech and PhD, then joining a semiconductor career at Intel, that was by choice.
Great, great.
Thank you.
So,
Thank you, Satya.
I think we are more lucky that you selected semiconductor and you are here for us to be a mentor. Actually, I was really listening to you so nicely, and I was able to see that how easily you are able to relate satellite, UPI, and a chip. Everything behind UPI or a satellite, there is a chip. And you have to learn the chip whether you want to be in finance industry or whether you want to become a space scientist. So everything works on electronics, which is being controlled by a processor, which is being designed by a VLSI engineer. So like all the dots are being connected so beautifully that a student who is really aspiring to become maybe a fintech engineer or maybe a like satellite engineer or tomorrow electronics engineer, whatever you want to become, you need to understand what exactly is happening behind the screen. And this complete program is to understand what exactly is happening behind the screen. And I really thank Chitra ma'am and Satya Gupta sir to give us a better perspective about what exactly is happening in the better industry. And now let me just call the person who is really going to walk you through this whole program, who is going to hold your finger like a parent and walk you through each and every step of how exactly the chip is going to get designed and maybe manufacture if you're very much interested to manufacture it and sit in your own gadget. So let me invite Kunal Ghosh, the founder of VSD, who also considers himself as a child because he always likes to explore and he always wants to work with youngsters. He always tries to work with the college students, the school students, and he wants to learn more from them. Whenever I ask him, why are you always learning with college students? He says, these are my teachers. They tell me what exactly is needed, what exactly they want to learn. Like there are mentors who tell you how to make them understand, but these are the students who tell you how to make them understand. So I really appreciate his energy, and I invite Kunal to hold your finger and take to this journey ahead.
All right. So, good morning, good evening, and good afternoon, all of you from all over the time zones. So, first of all, let me invite one of my partners, one of my team members, Matt Wen, who is who is going to supply the technology behind it, and then I'll start with the curriculum. So, let's first understand what the technology is going to be on what you're going to design your chips. And then we'll talk about the curriculum. So I'll just unmute Matt Wen. Matt, yeah, I'll unmute you. And yes, Matt, over to you. You can share your screen.
Yeah.
Hi, Matt. First of all, thanks for joining on a very short notice. Really appreciate your time and effort on the entire platform. And yeah, we would love to hear your perspective.
Great. Let me know when you see my screen.
Oh yes, it's visible now.
Yeah, that's the wrong one.
And we can see a chip.
No, it's gone.
Oh, it's gone again. Yes, visible.
Okay. And the audio is okay, is it?
Yes, it's perfect.
Great. Okay. So yes, hello everyone. Thanks for joining today, and thanks the VLSI team in India for inviting me to present today. I'm pretty excited, and it's great to be talking to so many young people. So I'll try to keep it quick and interesting. Kunal asked me to talk a little bit about why you would want to learn about chip design and how we're going to do it. So I hope there's not too much repetition here. Just in the comments, write if you've ever used an app. Just write the word app. Okay, yeah. Now, how about if you've written a computer program? Write the word program. Yeah, plenty of people used computer programs and apps, of course. Okay, here's a hard one. If you can count up to 16 in binary, write the word binary. Oh yeah, we've got some, that's good. Just type in how old you are in the chat. Cool, okay. Great, good range of ages there. Okay, type circuit if you've ever built your own circuit. Sasank, I don't think you're 10,000. Okay, a lot of people have hands up with doing hardware. So I built my first circuit, I think, when I was 14. How about if you've designed your own circuit? Write the word design. Okay, Sasank, having a joke at my expense. Still, I approve. It's a good joke. Designed, okay. How about if you've designed a chip? Write the word chip. Oh, got a few people in the audience. All right, how about this then? Have you had your own chip manufactured? Type in the word fab, F-A-B. Oh, Nandi has. Okay. How about if you've manufactured your own chip?
Nice.
I have to ask that question because one time I had Sam Zaloof in the audience and he has actually made his own chips. So there's a wide range of here, but I think we can agree that more people have designed their own apps or written apps or have done a bit of programming than they have actually done chip design or even had their own chips manufactured. And we've also heard from the previous people speaking, we've had this massive acceleration of technology from 20 or 30 years ago up till modern day technology. And I'm sure you all have a telephone that looks more like on the right of this picture than on the left. And if you look inside a telephone, and I took this video screenshot from a video, I'll share my link to my slides later, but there's a great YouTube channel called Branch Education who explains how a lot of science and technology works. But we've got this big chip in the middle of the phone that does most of the work. An example manufacturer is Qualcomm, but we've also heard Intel, Apple make their own chips. And talking of Apple, this is one of their more recent chips. And I just want to draw your attention to these two numbers, 5 nanometers and 16 billion. So a nanometer is 1 times 10 to the minus 9. So you have to divide by 10 9 times to go from a meter down to a nanometer. And 16 billion, a billion is 1 times 10 to the 9. So you have to times 10 by itself 9 times to get up to the number of transistors inside a chip. So just to give you a bit of a view of that, here we start off with 1 meter, times by 10 3 times, times 10 times 10 times 10, get to kilometer, times 10 times 10 times 10. And we're looking at the surface of the Earth. And we go another 10 times 10 times 10. And in the middle of this picture, we've got the Earth, and the oval is the orbit of the moon. So that's the difference between 1 meter, 1 times 10 to the 1 times 10 to the 9. And going the other way around, zooming in, dividing by 10, we divide by 10 3 times, we get to 1 millimeter. We divide by 10 6 times, we see the holes on the wall of a cell. And we divide by 10 9 times, and we get to the building blocks of DNA. So this is the scale that we're operating at, which is really just so awe-inspiring, really, for me. I still can't believe that we actually do this, and we make millions of mobile phone chips every day, and you're all walking around with a telephone with billions of chips inside, and the active devices inside those chips are called MOSFETs. They're mostly FinFETs, and they're on the scale of 1 times 10 to the minus 9. They can only be made by these incredibly special machines. This one is a $100 million machine made by AMSL. There's only one company in the world that can make machines like this, based in Holland. And they're typically only made by, at the moment, one company called TSMC, based in Taiwan. And this factory, a new factory, uses those machines, and it cost $18 billion to build this factory and fill it with these $100 million machines. So it's a very important industry that really stretches the breadth and depth of science and technology. Now, Kunal asked me to say, why is it important for young people to learn to design chips? And
Yes.
Yesterday, I read the US National Science Foundation's Educational Workforce Report, which was just released a couple of days ago. And I just got a few highlights here. The main recommendation of the United States National Science Foundation is that accessibility is the key design, and that community college and high school students start learning. Open source options should be emphasized. And the critical challenge is how we can educate and establish a workforce to actually continue creating designs and running the machines in the factories. So without you, young people, having an interest and getting involved, we'll run out of people who can help us to keep on making the kinds of chips that we all depend on, like was highlighted by the previous speaker. We all use 100 chips every day in our life. So if you're interested to learn more about that, there's a 50-page PDF. You can download it from there, but I just put the highlights in here. So how can you get involved? Well, we've been working on a great program called Tiny Tapeout, and it starts off by learning how to draw the most basic digital circuits in your web browser. So you draw a circuit like this in your web browser out of the most basic building blocks. Maybe I'll just give you a quick demonstration. So if we can go here to the WOCWI project. Here's a project that is doing traffic lights, and I can start the simulation here. And then down over here, we can see the traffic lights are running through the red, yellow, green. And I can build my circuit by dropping in components like this. An AND gate, for example, a very simple gate. And I can wire it up by drawing wires in my browser. So after you've built a circuit like this and you simulated it, what we can do is we can put it through an open source GDS flow. So we take your WOCWI design and we run it through an application called OpenLane. And at the end, we get the GDS files, and the GDS files are what we send to the factory to actually get your designs manufactured. And here's some examples. So something that converts binary to decimal. I know a lot of you can count to binary. This uses 25 cells to convert a binary number to a decimal number. Here's a counter that can count up to 8 bits and needs 49 cells. And here's a 4-bit counter with a binary to decimal converter, and that takes 50 cells. And then what we do is we use a platform called GitHub. We put your WOCWI design inside a GitHub repository, and then GitHub installs the libraries that you need to make a chip along with the OpenLane tool and builds the designs for the chip on GitHub's servers. And this design needed 12% of the area being used. It used 4 millimeters of wire, and you can see all these standard cells being used. So the AND gate that I showed you earlier, I can click on that and get a bit more information about this AND gate. My favorite thing is the 3D viewer. So I can open the design up and I can see here's all the designs, and you can really see, okay, that design that I drew out on my computer, this is how it would actually get laid out and manufactured. And I can work my way down through the metal layers and see the standard cells, the AND gates, the OR gates, building up these standard cells. And let's just pick one. and isolate it and see the different layers in the silicon that actually make chip design possible. So we give you all the way down into the silicon level to understand how it's possible. Now, we've already done this 5 times now. We've sent off 5 different chips to get manufactured with people's designs on. People like you submitting designs, we actually get them manufactured. And we recently got Tiny Tape Out 2 back. I'm holding up a Tiny Tape Out 2 board here with the silicon chip in the middle with all the designs. So Tiny Tape Out 2 had 165 designs on it. We had the chips made, and now we've got these boards made, and we're working on sending them out to the people who are involved. All the little designs get aggregated together into one big design. Here you can see we've got a zoom in of these designs here. So like, here's that traffic light example. We send them off to the factory. Takes maybe 6 months, 9 months, a year or so to get made. It's a very long progress. And then we get the chips back. Here's a big picture of the board. Because there's so many designs on there, you have to select here in binary. So if you had 16, you'd have to set 1, 0, 0, 0 to set it to be 16. And then you've got your 8 inputs here and your 8 outputs down here on the LED display. And that connects up your design in a custom chip and lets you access it with the inputs and outputs. One of my favorite things is that we ask everyone to write a bit of documentation. And I've got my documentation here. Then I can flip through, find design 16, and then work out how it works and enable it. Because if you submit a design to our program, you'll get your design, but you'll also get all the other people who submitted a design as well. And you can test their designs as well as testing your designs. So we got the chips back from Tiny Tape Out 2, and they're working. So this is a nice persistence of vision demo. By putting the board through the air really quickly, you can see the letters here spelling out Bitlooney loves ASICs. And we also had one that drives an LED controller here, LCD. And if you want to watch some more demos, you can check out this video. And just to finish off, I'd like to say thanks to our sponsors, eFabless and Eisler, who have supported the development of this project. And if you want to get a link to my slides, then here's the QR code, here's the short link. And if you want to follow me or connect with me on YouTube, Twitter, or LinkedIn, then my details there. So thanks very much for your attention. I really hope that you get excited about chip design and you take part in this program. And I really look forward to getting your designs manufactured onto a real chip. And Kunal will tell you more about how that's going to work now.
All right, good. This was really a great presentation. So everybody who liked the presentation, just type yes in the chat box. I'm sure all of you, because
Yes in the chat box.
Yeah, so see, you can see the responses which is coming up over here. It was really great. The way you summarized the whole thing in a span of 10 minutes, that's really cool. And so our vision statement over here is that all of you who have joined currently in this particular program, the program will go for 2 months. And at the end of 2nd month, you should be able to speak the way Matt is speaking in front of all of you. That's the entire goal. And I'm very sure we'll be able to do that, because the way we have designed the content, the way we have, you will be getting the access to the entire LMS website, and you will be getting hands-on on how do you basically design chips the way Matt just explained. So all of this will be a part of the entire 2-month schedule, but we are going to go there step by step. We are going to go there level wise. So let me quickly show you the first level that all of you are going to do. So I'll share my screen, and I just made my slides a little bit in the comic format, because I am expecting a lot of college participants over here, and so I wanted to make it a little bit more interesting. And this is something which my team suggested to do it, so I've kept it in this way. So our goal over here is okay. Just there are 2 things which I wanted to check. Everybody has joined the WhatsApp group. Just type if not, I'll just share the WhatsApp link again. 1 second, because everybody needs to be a part of the WhatsApp group. So I'll share this link with all of you. If you haven't joined, this is the link, and just make sure you have joined the WhatsApp group, so that all your Q&A will be shared over here. And second thing, I've also sent some one link to join the program, which I'm going to share again. But anyways, let's get started with the main thing. So what are we going to what are we going to do over here? My team's I'm Kunal Ghosh. I'm the founder of VSD, VLSI System Design Corporation, and the company started like 13 years back when we just were passed out of college, and the vision statement was pretty clear that how do we make chip design more interesting. That was the vision statement, and I'm glad now we are at a position where everybody where it has been brought down to certain level, and the goal is to even make sure that even the 5th, 6th grader, 10th grader should also be getting inside the chip design area, and I'm very sure Matt and others might have got a variety of ideas to do that as well. So slides are being done. It's been done by my team, my entire VSG team, and I'm just presenting. I'm the presenter for the whole slides. Now, the way we are going to progress this whole thing is by asking questions to all of you, and that's where the lectures are also designed. The first question that let's see, what do you guys already know? So everybody knows about potential energy. Just type yes in the chat box if you know about what is potential energy. And we're going to go a little bit of technical. Slowly, we are going to get to the technical part. Just type yes if you know what is potential energy. Okay, so all of you also know what is kinetic energies. Like I'll just follow Matt's technique. Type kinetic. If you know what is kinetic energy, just type kinetic in the chat box. Just type kinetic in the chat box. Okay, good. So you know both these concepts. Let's move a little bit ahead. All of you know what is current. If you know current, just type current in the chat box. If you know what is current, type current in the chat box. So Matt, this really works. I'm glad I learned this technique from you. All right, everybody knows what the voltage is, and everybody must have heard of the term voltage. If yes, just type voltage in the chat box. And now, by the way, if you haven't heard about these terms, these are also the terms which will be covered as a part of the entire LMS program, and it's as a part of the next level 1 program. These terms will be going to be covered as a part of the LMS program. So if you haven't heard of it, don't worry, it's also a part of the entire curriculum as well. Okay. Now let's see. Everybody knows that we can convert a potential energy to a kinetic energy. If yes, just type P2Ke. P2Ke. Yes, so we know that energy can be converted from one form to another form. Okay, now there is another concept which I think most of you might or might not be aware, which is again a part of the entire program, that the stored energy, whenever you store an energy, it's called as the voltage, and the moving energy is called as the current. And then again, something which you might be aware or might not be aware, and that's fine, because these are something slowly and steadily we are going to take you from the energy concept to the voltage and the current concept, and to the moving energy and the stored energy concept. So these all things will be covered, so don't worry about it if you are not aware of this one. Now going a little bit higher. So did you know that the flow of energy in balloon, if there is a balloon, we must have used the balloon in birthday parties. So the flow of energy inside and outside the balloon is very similar to the flow of energy in the battery. That is something which we are going to come up with a concept on how does the energy flows, and from that we are also going to derive the Ohm's law. Ohm's law is a very fundamental law, and which we are going to use very frequently, is a part of the curriculum which has been designed for all of you. And the flow of energy is flow of energy in the battery will be related to the Ohm's law. Now these are some of the topics which we had done as a part of our high school or first year engineering colleges, but some things is something which is we are going to cover as a part of the entire program as well. And now, did you know that there are different kinds of switches? There is a slide switch, there is a dip switch. These are the different kinds of switches that you must have seen manually or physically on your when you do some DIY kits. So there are different kinds of switches, and a switch, when you connect to an LED, that particular operation can easily be converted to how a complex chips actually work. So once you understand the fundamental of how a switch is connected to the LED and the functioning of it, it can very well expand it to how a complex chips actually work. So all of this again are a part of the curriculum which is going to be shared with all of you very soon. and and then your task, so your task for the next 15 days, I mean your deadline is on 30 November. Your task is, first of all, watch the video. So everybody got access to the platform. I mean, we had given you access to vsdiit.com. Everybody has got access to the platform. If not, check your email IDs. I have sent you detailed detailed login ID and password. So it's very simple. It's very simple. You go to the website. I'll share the platform link right away, and so that all of you go to this particular link. So all of you go to this particular link which I've shared in the chat box, and your login ID is your platform login ID is your email ID which you have used to register, and password is VSD IIT. It's all there in the email. So I've shared the details over email. If not, you ask me on the WhatsApp group, or you can also email me if you have not got the access to this one. But your this is where all the tasks are basically hosted. All the videos, the labs, everything is being hosted over here. So your first task for the next 15 days is to basically watch the videos on the platform, do the labs on the platform, prepare a Word document. It should be minimum of 2 page. I mean, it should be and at least 2 page of Word document, and submit that particular Word document on 30th November. How to submit the Word document is something which we are going to explain very soon. But this is the first task, and people who complete the first task, they are actually going to the second task, level 2, which will be explained on the 30th November when we have the second session. But the first task is, I'll repeat again, watch the videos which is there on the platform, do the labs. The labs are very easy labs. We have kept it very easy, very simple labs on the tiny tape out engine which Matt just explained. There are 2 or 3 labs which we expect you to do. Prepare a Word document, minimum 2 page, maximum, it's up to you, but I'll suggest minimum 2 page of document, and submit that as a part of the 30th November. Now, any questions, or have we understood what needs to be done by 30th November? Just type yes if you understood, and if you don't understand, it's also fine. We'll ask the questions. We'll reply the questions on the chat box. So let's take a couple of questions over here. So, okay, the first question is, do we have to prepare 2 documents daily? No, not daily. The entire summary, you do watch the entire videos, do the labs, and prepare a 2-page document. Okay, that's all. Whatever you have. 2 page at the end of the session. Yeah, not daily, 2 page at the end of the session. Okay, is there an age limit? No, there is no age limit, because it has been minimum 10th grade student should be able to understand what is there on the videos, because there are a lot of graphics, there's a lot of text that has been covered as a part of the LMS, as a part of the video document. So you should be able to very easily understand, and the entire fundamental has been converted, or it's basically related to the real life concepts. Whatever you do in real life, it's been basically very much related. So you should be able to understand. And in case any doubts, you have the WhatsApp group. You can always put a question and we'll be able to answer you. So document only whatever you have learned by watching the videos and by doing the labs, a summary of what you have learned. That's all we need. A document should be a summary. You can put snapshots also of the labs if you want. That will make it more attractive. But minimum, we expect that a document should have the summary of what you have learned. Okay, it can be a Word document, and you have to convert the Word document into PDF when we ask for submissions. That's what we are going to do. Can we do a Notion doc? I don't know what is Notion doc.
Aditi Arvind has a question.
Yeah, so are there any particular videos on the platform that we have to see? I have not registered yet, so I am a bit confused how the system works. Yes, so there are 8 videos, 8 fundamental videos, and 4 lab videos which is updated on the platform. And if you have registered for the event, you must have got a email from us with your login ID and your password. You just need to log into the platform, and you should be able to see the videos and everything on the platform. You just need to watch the videos, do the labs, and at the end of the day, prepare a summary of what you have done at the end of 30th November. So on 30th November, you have to submit a summary of what you have learned in the next 2 weeks. Okay, 2-page document should be about the entire summary of what you have done in the next 2 weeks. Next session happen. So next session will be on 30 November when we are going to receive your documents as a part of the lab work. We're going to receive the documents and we are going to explain what is the next session going to be. Videos are all updated. It's all there on the platform, and once you log into the platform, you should be able to see the video. So it's all 24/7 open. The video lectures and the platform is available for you 24/7. You can just log in and the videos are all there on the platform. You can start doing right away. You can start working right away. The labs are also explained on the website. The way the labs has to be done. It is all explained on the website. So it should be very easy for all of you to understand. 8th grade are allowed. You can just go through the videos. It is explained in a part of the way things has been explained. It's related to your real life. Whatever you have been seeing till now, whatever you have studied till now as a part of the as a part of your school curriculum, it's very much related to it. We have tested this whole thing by a 5th grader. There was one of our colleagues daughter who is a 5th grader. So we have made sure that she understands the whole thing. So I'm very sure 8th grader should be able to understand. Just a little bit of effort, and I think you should be able to do it. Certificates, we'll talk about it later. It will be talked about towards the end of the session. Now, and I think remaining questions are quite repetitive. I'm seeing if there is. Yeah, 8th graders are all allowed. I mean, we have tested with the 5th grader students, so we should be able to do it. Okay, some of you have failed to register. Yeah, so we will do this. We have to see. Now we cannot accept new registrations, but we'll talk about it later. So period of the course, total it will be 2 months. The first level will be 15 days. You have to finish the level 1 to move to level 2. The people who complete level 1, they will be allowed to move to level 2 because you should show a progression in your task. Once you progress from one task, you should be able to go to the next task. So that's how it is going to be. The first level will be for 15 days. Okay. So 2-page document, minimum 2-page document, Akhileshwari. It will be a summary of what you have learned. You can type the summary of what you have learned, and better to have it more detailed. If you have it more detailed, more the better. If you are learning the entire video and trying to summarize the entire video, good for you. It will be stored as a document. Else, minimum which we expect is a summary of what you have learned, a summary of the labs. A progress report can be typed in Word document. Better to have it in Word document rather than hand document because Word document is easy to read and to evaluate. So better to have a Word document. So this session is also recorded and we will upload it on our website. These are all free sessions, and fortunately, all of you are right now fortunate because you are getting an access to a course which is completely free for all of you. In a real scenario, in other universities or other institutes, the same program will charge you close to about minimum $500 to maximum $2,000. VSD ourselves, we basically charge close to $450 for this kind of sessions. But all of you are really lucky to have got this entire thing covered by Intel India, IIIT Bangalore, and VLSI Society of India. So all of you are really lucky. So make sure you learn as far as possible in this entire program because it's completely free of cost, and you will get the certificates from the best of the universities. Yeah, end goal is you have to manufacture a chip at the end of 3 months. That's the end goal, Arif. At the end of the day, you should be able to view your chip the way Matt showed you a couple of minutes back. That's the end goal, and this is just the next 15 days is a starting point to reach there. Yeah, if you have completed your graduation, also you're eligible for this particular course because the task levels are going to be increasing day by day. So everybody who has done and plus you're also going to cover the tape out. We are going to cover a good tape out curriculum also. So definitely you're eligible for this particular course. Yeah, password is again, I'll repeat the password is VSDIAT. I've typed it again. And So train AI using NLP techniques, that's a different science, but you will be able to understand what is happening in that domain. But this is where all of things get started. And rest all are very common questions, I think, which we already have replied to all of you. And later on 30th November, we will be having the second session where you're going to talk about level 2. All of the participants who basically finish level 1, they are going to go to level 2, and what is level 2 we'll be explaining on 30th November. So just make sure all of you complete level 1 by 30 November. And are we going to tape out the chips? How are we going to do it? All of these things will be very much clear as and when we go to go through the next levels of the program. So level 1, just finish the labs and the videos explained on the platform. Level 2, we are going to explain on 30th November. And how are we going to exactly do the tape out? So just proceed with the next levels. It's like a game. So everybody has played Mario over here. Yes, everybody has played Mario. That's a basic game that everybody must have played, right? Just type yes if you have played Mario. Type yes if you have played a game Mario. Yeah, right, Mario. So Mario, you have level 1, then level 2, then level 3, right? So first finish the level 1 of the game, and then we go to the next level, then to the next level, and then to the tape out level. Tape out will be the final level 4. But let's start with level 1. Once we finish the level 1, then we are going to go to level 2 and level 3. And how to submit the document, where to submit it, all of these things will be clear on the WhatsApp. I'm going to clarify all these doubts on the WhatsApp, where I'm going to share you a link where you can upload the document. That will happen later. It will be we are going to send a Google form on which you are going to upload your document. All right. Okay, so document again, same thing. I'll repeat again. We have to summarize whatever you have learned as a part of the next 15 days and summarize that learning as a part of your document. Okay, all right. I think most of the questions have been answered, and if I have not answered any questions, my WhatsApp channel is always open. You can drop me a WhatsApp or also type my number 9686 428727. So this is my number. You can save this number and drop me a question in case you get stuck somewhere. So what is level 2? We are going to explain, and stay tuned. We are going to explain about what is level 2 and what are we going to do as a part of the level 2. Just stay tuned. Only the level 1 participants who finish level 1, they will be explained about level 2, and level 2 will go to level 3 and things. It will proceed in that particular way. Okay, all right. So we'll start this process of building a strong chip design community, and we'll do that from your age, because all of you will have a long way to go. I can assure you that the moment you finish level 1, level 2, level 3, level 4, companies are going to invite you for talks, for sessions, for jobs, and things like that. That's what has been my experience. I mean, and also the students who have been working with me, it has been an experience with them. So it is going to happen very soon. But just make sure all of you cover all the levels in a very nice way. The lectures have all been uploaded on the platform. It's brought down to a very lower level where even a 5th grade student should be able to understand how to do the labs. So all the best to all of you. And that's all I had. Any closing words from Chitra ma'am or Satya sir? I mean, feel free to.
Yeah, this will be a new and great beginning. So let's play together, and then we will ensure that we reach. We'll get to the what is the highest level, Kunal? Level 4.
Level 4.
Okay. Good.
So I
All
saw
the
lots
best
of people are asking
to
questions
everyone.
here, whether the chip is going to get manufactured or not. And we really wish many chips should come out from this batch, because this will be the youngest batch to manufacture the chips. And I want this students to come up their own designs, come up there with their own chips and replace their chips with the phones and the switches tomorrow. So that is our vision statement. Someone is asking, what is the end goal of this session? The end goal is that the chip should sit in your own mobile, in your own gaming session, gadgets. That is the vision statement that we are planning to put it here. Best of luck, everyone. Let's design the chip.
All right. Thanks, Anaga. Thank you, Chitra ma'am, for joining.
Thank you, everyone.
Thanks.
Thank you.
Yeah. Thanks, Matt.
Best of luck.
Thanks, Matt.
Yeah, Matt, a great session. And we'll stay in touch on the WhatsApp group. Thank you.
Goodbye, everybody, and good luck.
Thank you,
Thank you,
Matt.
folks. Thank you. Bye.
Thank you. Thank you. Bye.